So what we want to work on next is solving multi-step inequalities, but in order to do that we need to do a quick review from things that we've learned earlier. Okay, if we look at the one on the left, it says x is less than 4, x is smaller than 4. So to graph this, what we want to be able to do is graph all the possible solutions. Well, anything smaller than 4, 3, 2, 1, -5, 0.4, all those are smaller than 4. So instead of writing a whole list, we make a number line, put some numbers on there. Maybe I'm going to put 0, 1, 2, 3, 4. And I want the numbers that are smaller than 4. So I put an open dot on 4. And the open dot means I can't choose 4, because if I choose 4, I'd be saying 4 is smaller than 4, which I know isn't true. So I'm going to put an open dot on 4, and then I'm going to draw an arrow going smaller, because I want all the numbers smaller than 4. Let's look at the next one. It says -13 is less than or equal to m. So again, I need some numbers on there. Well, the most important number I need is -13, so I want to make sure I get -13 on there. I can put more numbers like -12 and -11, and I can put -14 on there. But the one that I really need for this one is -13. Now, I can put a closed dot on -13, because if I choose -13, this would be a true statement. If I choose -13, it says -13 is less than or equal to -13. But I can choose other values for m that would make this true. I can choose things that are bigger than -13. So I want a number line. I want to choose solutions that go to the right on my number line, because I could choose -12 and this would be a true statement. I could choose -4 and this would be a true statement. I could choose the positives like 18 and this would be a true statement. So that's just a little review, something we've done earlier. Now, how do we use that? Well, just a reminder here, a closed dot looks like this, and a closed dot you use when your inequality symbol has an equal sign under it. And an open dot looks like this, and we use an open dot when it's a plain inequality symbol like that. Okay, just something to help you remember. I call it the Pac-Man. If the Pac-Man eats the letter, the arrow goes to the right. Well, if we look back here, in this example, the Pac-Man was eating the letter, and our arrow went to the right. Pac-Man eats the number, the arrow goes left. Well, if I look back here, the Pac-Man was eating the number in this example, so the arrow went to the left. So just a way to help us remember that if you need it. Okay, a little more review, solving one step, which we've done before. 2 next to x means 2 times x, so if I divide by 2 on each side, x would have to be less than or equal to 13. And then graphing it like we just did, I for sure need a 13. I would use a closed dot on this one, and I want numbers that are smaller than 13. The closed dot says I could use 13. Same thing here, 9 next to m means 9 times m. I'm going to divide by 9 on both sides. 45 divided by 9 is 5. Bring down the inequality symbol. Make my number line. For sure I need a 5 on my number line. I can put more numbers if I want. I'm going to use an open dot. The m is on the small side of the inequality symbol, or you could say the Pac-Man is eating the number. So I want numbers down here like 4 and 3 and 2 and 1 and -8. All of those would be solutions. Alright, now that we're done reviewing, we can do multi-step inequalities. And to do this, we do the same thing we've been doing with multi-step equations. Okay, I want to get the a all alone, so I'm going to add 9 to both sides. Now I've got 5a is greater than 20. I'm going to divide by 5 on both sides. 1a is just a. Inequality symbol drops down. 20 divided by 5 is 4. I know that I need numbers that are bigger than 4. So I'm going to put a 4 on here. Open dot, a is greater. So I need numbers up here like 5, 6, 12, 24. So you're going to try letter B and then check back and see how it goes. hopefully you've tried it. We're going to add 6 to both sides. Negative 10 plus 6 is negative 4. Inequality symbol drops down. 1/2 x. I need to divide by a half. Divide by a half. So if I write that out, it says negative 4 divided by a half. Well, that's the same as saying negative 4 over 1 times 2 over 1. Well, negative 4 times positive 2 is negative 8. So on the left side, this whole side turned into negative 8. A half divided by a half turns into x, 1x, and the inequality symbol drops down. I have this. Negative 8 is greater than or equal to x. And again, to graph it, I can make a quick, easy number line. I need negative 8. I can put more numbers if I want. I need a closed dot. And let's see, the Pac-Man, or the inequality, is eating the number. That means x is on the small side. I need smaller numbers. So I need things like negative 10 and negative 24. Same thing here. I need to get this all alone, so I'm going to subtract 17. 14 minus 17 is negative 3. Inequality symbol drops down. I have 1/2 c is less than negative 3. I'm going to divide by a half. Half divided by a half, that's 1. 1c. c is all alone. Inequality symbol drops down. I'm going to write this out as negative 3 over 1 divided by a half. That's negative 3 over 1 times 2 over 1, which is negative 6. So I've solved my inequality. Now I need to graph that inequality. Negative 6, open dot, and c is smaller, so I want all the smaller numbers. Okay, so that's how we do multi-step inequalities. Another quick review for us. Divide by 2, divide by 2, so x is less than or equal to 13. Well, if I think about that, here's 13, close dot, x is smaller. I want all the numbers down here. Let's substitute just to test this out. I'm going to pick a number smaller than 13. I'm going to pick 10. If I substitute 10 in here for x, that says 2 times 10. That better be less than or equal to 26. 2 times 10 is 20. 20 is less than or equal to 26, so it worked. Going to do the same thing here. Divide by negative 9. Divide by negative 9. Got m all alone. 45 divided by negative 9 is negative 5. So if I graph this, I need negative 5, an open dot, m is on the small side, so I need something down here. Let's substitute negative 7. So the original problem said 45 is greater than negative 9 times m, and I said let's try negative 7. 45 is greater than negative 9 times negative 7. That's 63. 45 is not greater than 63. That means we've got an error somewhere. And if you remember back, and it's okay if you don't, if you remember back, we had a rule. We said in inequalities, if we divide both sides by a negative number, or multiply both sides by a negative number, we needed to flip the sign. Dividing by a negative is like doing the opposite. So what we needed to do, after we said, hey, divide by 9, right here we said divide by 9 on both sides, we needed to bring this inequality, the Pac-Man mouth down, and we needed to flip it. So instead of it going this way, it needed to go the other way. So the negative 5 stays in its spot, and the m stays in its spot, but the inequality symbol needs to flip the other way. Okay, so if you divide or multiply both sides by a negative, you need to flip the inequality symbol. So if we graph this, again we got negative 5 and an open dot. M is greater, so we're going to go bigger than negative 5, things like negative 2 and 0 and 7 and 12. Let's substitute one of those and see if that works. Bigger than negative 5, let's pick positive 3. So let's try that. 45 is greater than negative 9, and I said let's try positive 3. 45 is greater than negative 27. Absolutely, that's right. So the whole point of doing this was to remind you that if you divide both sides of the inequality by a negative number, or if you multiply both sides by a negative number, you need to flip the inequality so it's pointing the other direction. Alright, so here's 3 more for us to try. Let's see, we want to subtract 4 on both sides. I've got 30, negative 2m on this side. Going to divide by negative 2, m and 15. Let's see, I divided both sides by a negative, so we're going to flip the inequality symbol the other way. And now to graph this, we're going to put 15 on our number line. It's a closed dot. M is greater, so our arrow goes that way. Let's try this one. For this one, sometimes kids don't like it because they want to have the variable in front. That's okay. If you want to move to the variable to the front, we can do that as long as it's addition, commutative property of addition. So we would say plus negative. Now it's negative x plus 6 is greater than 3. And a lot of people remember that's a negative 1 there. So now we can subtract 6 on both sides. I get negative 3 and negative 1x. Our whole goal is to get x all alone, so we're going to divide by negative 1. And when we do that, we get 3 on this side, but we divided both sides by a negative. We need to flip the inequality symbol. Open dot. Let's see, x is smaller, so we go to the left. Next one, same thing, but it has decimals. It's okay, decimals won't hurt us. We're going to add 2.7 on both sides. Let's see, 8.3, 2 plus 7, 11 on that side. Negative 0.5b on this side. We're going to divide by negative 0.5. Divide by negative 0.5. b is on this side. I know I'm dividing by a negative on both sides, so right away I'm going to flip the inequality symbol. Now I know positive 11 divided by negative 0.5 is going to be a negative, and then I just have to set up a quick side problem. Move my decimal. Negative 22. Number line. I need negative 22 somewhere on it. Looks like an open dot. And my arrow goes to the left. How can this get used? Well, here's an example. A stereo salesperson earns $1,900, $1,900. $1,900 plus 4% of their sales. 0.04 is 4%. Times their sales. Well, we don't know what their sales are, so we're going to write S. They want to earn at least $2,200. So they want to earn more than $2,200, or they are okay with exactly $2,200. We're going to do all the same things we've done before. And now we'll divide. And since we're dividing by a positive, we won't flip the inequality symbol. And then we just set up a side problem, 300 divided by 0.04. So this person needs to sell $7,500 worth of electronics to make their goal. It's okay if their sales are greater than or equal to $7,500. Good luck with multi-step inequalities.